We're here to solve this challenging Skyscrapers by JinHoo Ahn called Three's Company, where all the clues are paired and has a 3 with something else. The 8 is a quick place to start on this puzzle, and then the 7 even coming down will be the next one. We've got some large digits here, but we can't have an 8 right near the 6 clue. We also can't even have a 7 or 6 near this clue. I think 5 is the largest value this cell can take. So you'd see 1, 2, 3 if this were a 5, 6, 7, 8, 6 total buildings, which means the 7 and the 6 have to dodge, but still be here. Again, the 7 needs to have just the smallest amount of things seen. So actually have a little bit of a ladder coming up here to make 7 buildings seen, but this 5 eliminates the 5 options. So this is 4, 3, 2, 1. This is a 5 actually in that cell, and then as we said, it's going to see a 6, see a 7, see an 8, and it also has to see these cells. This will have a 1 or a 3 and a 3 or 4. So those look to be the starts from the 7, 8, and 6 clues. Let's spend a little time and see if we can mark the other 8s in the grid. This 4, 3 pair means an 8's in the center. This 4, 3 pair means an 8's in the center. So these actually mark off the center column. So this 5 has to have an 8 over on the right side here. So these now are marked off, which means the last 8's are in these 2 cells and these 2 cells, and the 3 up above forces 8 to the left, 8 to the right here. So we got this start. Can do a little more, I think, with the 5 clues. So let's see that this 5 has to be a smaller value than this 4. So this is a 1, 2, 3 cell. This probably still is a 1, 2, 3 cell. So if this were a 6, we'd only see 4 buildings in this space. So those all look to be helpful cells to mark. This 5, well, it could be 1, 2, 3, 4. If this is a 4, see 5, 6, 7, 8. So I think something about, is that a possible deduction will matter? And this may be where something that's useful is to look at this next column actually and say, where does a 7 go? Well, 7's not in front of the 3 clues. It's not in front of these cells we've marked. This 7 is in that row, 7 in this row, not in front of those 3 clues, so 7 is right here. So this cell is not able to be a 7. So again, where you're saying 4, 5, 6, 7, 8, this doesn't work. So 4 doesn't work in this cell. We're actually going to have a case where we might still see, actually, can we see just these buildings as visible buildings? If this is 3, we could have 4, 5, 6. That still doesn't work. It looks like these 2 buildings have to be seen. And then others may still be seen, but this building being seen is required. So this is a 3. 1 is eliminated from the cell actually as well. So this is a 2. This is a 1. How does this then go? So this is now a 4, 5 cell. So this is never seen. So this is going to be seen. So this is 4, 5, 6. This is 5, 7 coming up. So these 4 buildings with this building make the 5 clue work out. This 4, 5, 6 has to have a smaller building here. So where it's not a 3, this could be a 5, this could be a 4, this could be a 2, this could be a 1. This 3 puts a 4 in here. And with 1 and 2 to the left, this can be a 3 or a 5. But notice if this is a 5, it's going to hide all these buildings here, again, based off stuff we already know. So this is a 3. 3 sees 4. So those have to go away. This is forced to be a 2, which means this is a 1. So that all looks good. This column now has 6 and 5 to go, and the 6 is going to have to hide the 5. So we have 6, 7, 8 as the building scene. So these get placed in. This 6 means this cell no longer can be a 6. So this is the only place for 6 in the column, which means this must be the 7. We've got a 4, 5 at the top. So pretty hard deductions, but we actually got most of the first 3 columns here. So let's see if we can figure out what that means coming further to the right. And it may be we should start looking at some of these clues that may now be impacted by these values. Here's actually a starting one. So one question we can ask at the start is, did we see all 3 of these cells and then like the 8 right here? If not, we're going to have a hidden building and the 8 over here. And so once this 1 is down here, this 3 is no longer a visible building. So the only way this 4 clue works is with these 4 boxes containing those values. So 8 goes to the left, and actually 2, 4, 5 as a stepladder are written straight in. 8 coming over here looks good. This has some options. This looks to be a 1-4 cell. But actually, if this is a 4 with the 5 over here, this doesn't work, so this has to be a 1. This is 2-5 for this to go. If this is a 1, then this 4 from the top doesn't see just these 4 buildings. It has to see other buildings, so it's going to see this as the 8. So this 8 comes to the left, this goes to the right. See what else we have. Either a 6 is hidden here or a 6 is here, but a 6 isn't in the cell. So in this column, 6 isn't to the left. It's not here because this 3 wouldn't work. It's not here to the left, here to the left, here to the left. 6 has to be here. This down here is 4, 5, 7. And this cell is a 4, 7 cell, but it can't be a 7 because it would then cause an issue with the counts here because we would not see 3 buildings. So 5, 7, 5, 7 like this instead. These 4s then are pretty eliminated except for up here. So let's think about where does the 4 go. If 5 and 7 are hidden, then 4, 5, 6, 8, 4, 6, 7, 8 could work. So both of these are potentially 4s. Where are we limited with the 6s? So 6s are in one of these cells. Where are we limited with the 3s? We still have a lot of options for the 3s. So I think maybe the thing to do is actually look at this column again. Where does a 7 go? Not here, not here, not in these cells, not in this cell. This is the 7. So 1s go over the left and right. We have 3, 6, 7 here, not really specified. But one thing, I think the 7 going anywhere in this column before this clue is going to be a problem. So a 7 is going to have to be up top right here. We have just one cell left for a 2 then in this column. So this is now 1, 6, 3, so this will be a 3, 6. But here again, if this is a 6, that's going to cause an issue with the count here, so this has to be a 3, so we're just eliminating ourselves down by options that are available in these spaces. This is a 1, 6 coming across. This cell is a 1, 3, 5 coming to the left, but there's a 1 up above, so this is a 3, 5. This is still a 1, 3, 5. Looks like 1, 2, 3, 5 is a story here, so this is a 1, 3 cell. This is a 2, 3, 5 cell. So let's think about that. If this is a 5, we're going to have an issue with this 8, so it's not. So this is a 2, 3. If this is 3, making that a 2, making this a 5, then we'd see all of these buildings. So this can't be a 3, this has to be a 1, which means this is 6. 1, 6, 7, 6. That 7 makes 5 and 7. So that's some good progress. We now have that this is going to have to be an increasing series. This will be 3, 4, 4, 5, but there's no option for the 5 here, so this will have to be the 4 here, the 3 here, the 5 gets buried, but 3, 4, 6, 8, still a good set of cells to see. This is now left just being the 3, moving over the 1. That means 2 with 5. Last space for a 2 puts 4, 5, 3, and 4, and we're through the grid. So pretty hard workout, a lot of interesting steps at the start to really make these first columns work. Understanding both the limits of how this 5 gets seen, which requires seeing this building, but also that requiring like a 7 and 6 to be buried. These things setting up some different tension on the right side of the grid, including how like the 4, once the 1 isn't seen, doesn't see this 3, so the 8 moves over, and other steps like that, particularly I think eventually getting some constraints on getting a total count of 3 in the space. So really elegant and constrained Skyscrapers puzzles. So thanks JinHoo for the submission. Thanks for watching this video, and we'll see you again next week.